Welcome everybody. Thanks for being here. Johnny Do, good to see you as well. A good
You.
solid quorum here today.
Yes.
What's everybody up to? Who's on the road going anywhere interesting? What kind of projects are stewing? Tom John, how's things in
Well,
Monterey?
we just celebrated yesterday a little bit. We met to see each other, our team, and opening reservations on Start Engine for crowdfunding now.
Excellent. That's exciting.
Mm.
So people you're looking for investors and people can
Yeah, people can reserve shares. We want to build momentum when it officially opens. We want to have 100 investors roughly.
oh,
So
that'd be fantastic. And
minimum
Michael,
is
we're
$300.
okay.
Is that
Michael,
working?
it is. We're not ready for you yet, but we will be in a minute.
Oh, sorry.
No worries.
I
Brilliant.
was just checking it was still
Yeah.
functioning.
No, perfect. No, it's going to be good. It's going to be good. Excellent. Dom John, feel free to drop any notes about that opportunity in the chat in case people
Thank
are
you.
interested. Michael, good to see you here.
Thank
Michael
you.
Duke.
Good to be here.
Our Michael, are you going to be at the Electric Aircraft Symposium?
Yes, I am.
Okay, good. I might be there as well. We should talk about that offline. That'll be a good one.
Awesome.
Anybody else going to be at that one? That's
will you be able to speak there? I think you were invited, I think, Michael.
I was not invited to speak. I can if you'd like, but no, I have not received any invitations, but I am planning to be there.
Yeah, I'm sorry. I was thinking Skyfly.
Oh, gotcha.
Skyfly was invited.
Oh, where's that? Sorry.
Oshkosh, just before AirVenture.
What's the event? Sorry.
Oh, the Electric Aircraft Symposium.
and I did send you a note about that, Michael. It's the weekend immediately preceding opening day of AirVenture. So it's on the Saturday and Sunday in Osh.
Okay.
Love to have you there.
Yeah, I'll be around. I probably, yeah, I'm sure I can make that.
So Mike just dropped the link in the chat, and that goes for everybody. That's a fantastic event. And Mike Hirschberg, do you want to talk about it while we're on the topic?
Sure. And yeah, so well, I have you on the list I have Skyfly on the list as being invited, so apologies if that's not quite accurate. But yeah, so just share my screen for a second here. So it was started in 2007, I think, and we took it over many years ago. But the Electric Aircraft Symposium covers all types of electric aircraft, so short takeoff, vertical, horizontal takeoff and landing, all different types of electric propulsion, battery, hybrid, hydrogen. And it's a great event, usually about 200 people getting together before Oshkosh. And you can see here we've got a number of sponsors and exhibitors and speakers. And we're trying to confirm, the rest. There should be about 40 speakers like usual. And we've got exhibits and things like that. And this is kind of where the eVTOL and, electric aviation community started. So back in, 20 years ago, it was people like the founders of like Mark Moore from now Whisper, but NASA and Uber, and Joe Ben Bevert from Joby, and also Yosef Kalo from H2 Fly for hydrogen. So it precedes even the VFS eVTOL events.
Mike, if you can just let me know when the sort of timings and things, so I can make sure that I'm around at the time you want me to be.
Yeah.
that'd
Okay.
be great.
Great, we'll do. So everybody's invited.
It's a good one if you're thinking about going to Osh. It's fantastic because it's earlier, it puts you on a different schedule in terms of rental car and flight and hotel as everybody else. So it's makes life a little bit easier. And it's a great event. Anybody else planning to be there? Hit me up if you are. And the more the merrier. Sheena Banker is going to be there in a booth, right?
Yes. Yep. Hangar C for Sun and Fun. So we have an indoor and outdoor booth. We have cooling towels, which are our biggest swag item. So if it's like hot and gross, like it normally is, come get your cooling towel. Little shameless plug there. But yeah, we're announcing our next theme and all of that, and it's gonna be fun. It's really fun to go to another air show, because we just get to have a ton of fun while we're there. So we're not, running around running it. So it's super relaxed for us and a lot of fun. So yeah.
And
I
Sheena's air
will
show.
attest to that because I was at Sun and Fun. I mean, Andy was there too. I have to say, I'm impressed. I haven't
Well,
been there
thank
for
you.
many, many years, and this year I went there. I said, "Wow, that's not the same old Granddaddy Sun and Fun anymore." Very
Yes.
impressive. Yes.
Thank you. Thank you. Yeah,
And it-
we've put a lot of work into it for a lot of years now, and it's not just a little granddad air show anymore. So we came to play with the big dog.
I was impressed by the tech that I saw, and that's in no small part thanks to your contribution of pulling in the new tech companies and helping them out. Is that something that you're going to be working on for the show next year as well?
Yes. Yep. So we'll be doing the innovation showcase again, just like we have the last couple of years. I'm still running that, so I'd love to, get some more in there and around that whole the whole Future in Flight Plaza. We're revamping it a little bit, and it's, I'd love to have even more eVTOLs, especially like all electric aircraft, represented. So whether, you actually have a full-blown mock-up or you're flying, it was really cool. Pivotal got to fly during our day show and our twilight show, which was really fun. So if you're flying, we have the ability to do that too. So put you in front of a really big audience for that.
How big is the audience roughly? What is the range of attendance that you have?
So we had about 210,000 people throughout the week. Saturday we hit max capacity. So we parked over 18,000 cars alone on Saturday. So it was absolutely just packed. So our event report is out. I can email that over to you if you want to send that out to the group after. And then it's on our website as well.
Perfect. Sheena's been very kind to the whole AAM business. So if you're interested in reaching a large audience and maybe even doing some flying, you should definitely talk to her. That's going to be in April of 2026.
Yeah, April 14th through the 19th.
Okay. All right. Keep that one on the schedule.
Thank you.
Any other events ongoing that we should know about?
Well, we're all getting ready for Paris Air Show. Starts on Monday. So a few of us are heading over for that. I think worth noting that the CEOs of Joby, Whisk, Archer, and Beta are on stage together on Wednesday morning, 9 a.m., and being interviewed by Sergio. I think that's not being live streamed, so we might have to have somebody report back at the next one of these on what they say on Wednesday.
I hope it's you. We'd love to hear how that goes.
Sure.
Sergio's a lot of fun. That's going to be a good time.
And
Outstanding.
Mention-
don't
Sorry.
forget next week, the 19th, we have the public service working group meeting. Speaker from Netherlands, professor in the aerospace area. Very interesting topic she's working on. Anyway, we'll be sending out the meeting notice shortly. So please, everybody will join us next week, next Thursday.
Excellent. Mario-Lane is great. That's going to be a good meeting.
I also wanted to mention that two things: the VFS and SIFTY eVTOL Flight Test Council is having their webinar in I think it's in 2 weeks on June 26th. So that was the one that was announced. It was supposed to be at this time, and I said no, you can't have it at the same time as this TVF meeting, so they moved it. But they're going to be specifically looking at taxonomy and some of the terminology that they recommend. So that should be interesting. That's another one that like the TVF working groups. The eVTOL Flight Test Council has a number of working groups as well.
Excellent.
And in the end of January, we're going to be having our 13th annual eVTOL symposium, and it'll be in San Jose again. This is with the Army and NASA aeromechanics research, so they're looking for technical papers to be presented. The deadline for submitting abstracts is August 4th. But I put the link in the website, so this is part of our overall Transformative Vertical Flight annual meeting.
Cool. That'll be a great one.
It usually is.
Good.
And it's probably going to sell out, so just plan accordingly.
Good on it. I see Brandon Robinson's with us. Great article in Vertiflight magazine.
Hey, thanks. Really appreciate that. Yeah.
Yeah, and
I got to contribute.
At our annual forum last month, the video recordings for VFS members, we opened it to all VFS members, but we have we got an excellent presentation on Horizon from, is it John Wizakowski?
Yeah, John is he's a legend, right? So we're lucky to have him on board. He is absolutely awesome, and hopefully it went well. But
he was great.
Yeah.
He also made a few compare and contrasts with one of the previous companies he was at, Lilium. So that was worth its weight in gold there.
Yeah. John's great that way. We try to stay humble and just make solid progress. The thing I think that we're most proud of is just focusing on the end user, right? We're just building an awesome machine, and it's a less of a if you build it they will come approach, and more just a real focus on the end user. And I think that that's starting to resonate with a bunch of folks, and just sort of the authentic nature of how we communicate. We're honest with the challenges and where the tech's at.
Yeah, amazing progress, really.
Well, and technologically, pulling off a transition is a bigger deal than I think a lot of people realize. And you just did that, didn't you?
Well, the coolest thing about it, I mean, just within the small trust tree that we have in this forum, is that it was the most boring thing possible, right? Like nothing happened at all. Like there's no complicated flow attachments or detachments or whatever. It's just when the actual wings, because let's be honest, we've been all the way up to those speeds in multiple sort of different wing locations or panel locations. When they finally closed, nothing happened. It is the simplest thing possible.
Boring is good.
Boring, that's what I tell everyone. It was the most boring thing you could possibly watch, and boring is safe, and safe is awesome. So yeah, we were pretty stoked about that. And well, in the hangar, if you walked in now, you'd see full-scale propulsion units spinning up, and we have a cooling mechanism. Anyway, it's really interesting. We have a special air-cooled driven mechanism that we're testing. We have a full-scale propulsion unit on a dyno that is spinning up as we speak, and so we know that the tech scales as well, which is nice.
Congratulations.
That's awesome.
I would add that we just are playing with CFD more, and we could improve lift to drag ratio 31% recently. It's a breakthrough.
Oh, nice. Congratulations.
Thank you.
It's a big deal. Brandon, what's next?
Well, no, what's next is we're putting together the full-scale aircraft right now. So we have test rigs. So if you walked in the hangar, you'd see linear actuators working, testing the opening and closing mechanisms. We have full-scale CFD going on. We have full-scale propulsion units spinning up well, I mean, from an engineering perspective, the devil's in the details, right? So the construction of the individual battery cells and the overarching structure, keeping the power electronics cool in a very, very slick way, and then controlling noise, all the while just making something that works. And so we're building it, we're beating it up, we'll break it in a number of ways, we'll make it better, like Elon blowing up rockets sort of thing. So this is going to be a bulletproof machine when it finally comes together, and that'll be in the next 18 to 24 months. So all the key propulsion technologies and the underpinning. So we did our aircraft functional hazard analysis recently. We have 34 different subsystems or systems to consider. And we're working through the process of de-risking everything, starting with the most critical items that are in the catastrophic sort of level, and then working down from there. So with a huge focus on flight controls at the current state.
Outstanding. You got a full plate over there.
Yeah, so we know ducted fan technology is there. We can add like cool new modern electronics and carbon composite sort of lightweight structures, but we know the ducted fan technology is going to work. Keeping things cool and controlling them very precisely in a highly redundant way is the most important thing for us. So that's how we're proceeding right now.
Good.
Yeah, neat.
Well, it's gonna be fun to watch.
Well, and all of a sudden, all the engineering conversations have gone right over my head. So like, I'm a fourth-year engineering student. If I pull back on the lever, does it go up? And is it going to be stable? Like, yes. Okay, good. That's all I care about now. I'll just, well, you guys do your thing.
You got the smartest people in the room with you. That's good.
That's correct.
That's good. That's exciting. Well, we have an outstanding speaker with us today, but before I do an introduction, are there anybody else that has events going on or milestones that they want to talk about? Or maybe new folks that haven't been with us before that would like to do a quick introduction?
Hey, long time to see you. Yeah, I've been
Welcome.
like part of that group. Yeah, a while ago. Yeah, and in my company has been a lot of pivoting recently over the course of like last 2 years, and now I'm into integrating LLMs, yes, large language models, into regulated industries like aviation, because as you know, we cannot just trust AI, yes, trust the output that it gives us. So the key point here is to still keep the human in the loop and control for humans, so they can actually see what it was generated, do some small minor adjustments to some working cards, to some whatever documentation they're working with. And only after that, they can actually submit the documents or whatever they're working with. So we've seen this kind of things happening with GPT kind of in many industries and many cases, but we kind of reinventing, we try to put human in the loop for automated workflows. But what we do, we kind of doing from the scratch. Yes, we rethink about how it should be working, how humans will be working with machines in the future, working with documentation, working with some working cards, working with processes, physical processes that we have there, and where actually part of LLM will be in the future. It will be not full automation. We already understand this. Yes, it will be some only small minor part, and human will be in charge and be responsible for whatever they're doing.
Very cool.
That's it. That's yeah, where I am now.
Well, I hope you keep me posted and let us know when you've got some things you want to present and talk about at a meeting. I know people will be interested in your work.
Yeah, sure. I will keep you informed. Yeah.
Outstanding. Anyone else? All right, well, why don't we all switch to mute, and I want to introduce Michael Thompson. He's the founder and CEO of Skyfly Technologies. His journey into electric aviation began with his first venture, a pioneering drone services company that operated globally and was actually one of the first commercial drone operators in the UK. Through this business, Michael developed expertise in electric propulsion systems and their advantages in real-world applications. And also during this time, he earned a rotary wing pilot license, which gave him experience with the complexity, cost, and environmental impact of conventional aircraft. So it was this intersection of knowledge, electric propulsion, and conventional aviation that sparked the creation of Skyfly for Michael. Today, Skyfly is redefining personal aviation with innovative, efficient, and accessible, vertically capable aircraft called the Axe. So, Michael, with that, the floor is yours. And I think you might be muted.
Sorry, it's always a bit of a struggle with these screen shares, but we'll get there
every
eventually.
time.
Can you?
I'm telling you, I swear Zoom does it differently every time I log on. Okay, we can see the screen perfectly now. This looks fantastic.
Awesome. Perfect. Yeah, hi guys. Thanks for having me. So yeah, I'm the founder and CEO of Skyfly Technologies. We're a company based in the UK in Oxfordshire, just outside of London. And we're developing a two-seat vertically capable aircraft. And there's a reason we don't label ourselves as a eVTOL, which we'll sort of come on to later. But yeah, it's primarily focused on personal aviation. So you flying yourself and everything, all the joys that come with that. And then we're doing a defense-focused version. And sort of the training market falls into our realm as well. So providing sort of powered lift training, and then also sort of applications within emergency services, primarily in an unmanned configuration. But what's quite unique about our platform is that it's quite transferable. The next slide hopefully is going to work. It's just a bit of video to show you. So this is our first airframe, serial number 1. Serial number 2, 3, and so on will look pretty much exactly the same. The tooling's not changing for the airframe, but yeah, there's a lot of changes. As anyone that knows building a prototype, you learn an awful lot of things. So hopefully this will play. So yeah, it's a canard wing design. So it's got this useful sort of layout where you've got the ability to control it exactly like a quadcopter in the hover. But our design is unique in that we don't have any rotating propulsors. So we save a huge amount of cost, complexity. It's way less failure prone. It's a lot lighter. So you can do your conventional takeoff and landing as well. The aircraft can glide. It's got a sort of 6 to 7 to 1 glide ratio. So yeah, that's sort of the design. I'm going to basically start repeating myself in a second, but I think it's a nice video so people get an idea. This is fully piloted flights out here in Oxfordshire that we've been conducting since October last year. So you know, why did I start? Why did we design this aircraft? And primarily it's through my experience flying helicopters. And I learned on a Robinson R22, which is a fantastic machine. But primarily, I found it a little bit daunting at first, not the easiest thing to learn on, partly because it's, you know, it's a very lightweight machine and you're in control of the machine entirely. There is no special computer helping you. But that design has not changed in pretty much 50 years. So it's a real shame that that's happened, but that is the case. And the mechanical complexity involved in helicopters, we all know, is incredible, really. You know, main rotor gearbox, tail rotor gearbox, you've got a big piston engine in there. So all of that also costs money in maintenance mainly, but the overhaul is also a massive factor when you're looking at cost. Noisy, you know, I fly an R44 at the moment, and I do get a bit embarrassed landing it at restaurants because it is extremely loud, or a hotel, wherever you're landing in a private site, extremely loud, and it's just, you annoy people quite easily.
It also
so
produces leaded gas. I mean, lead in the atmosphere. The
yeah, exactly. So I think everyone's well versed on, you know, the reasons why you would want to update this whole market. So we're primarily focused on the 2-seat. We've got plans for a larger aircraft, but that is a long time in the future. But we're looking, our direct competitor really is something like the R22. So yeah, you've got a bit of an overview there of you know, the problem. We're stuck with these old aircraft that haven't been updated in a long time. So the Axe is it's not by any means going to replace the helicopter entirely. They're always going to beat us on range. That's nothing we can do about that with current battery technology. We are doing a hybrid version as well, but we do want to focus on the fully electric version first. So what the advantages we have with our design, obviously, it's using carbon fiber. Everything is carbon fiber. The whole structure is carbon fiber, which gives you a massive weight saving, and also it means you can build in a lot of the sort of safety side of things. You know, the R22 was designed without really much safety in mind. So we've also got an amazing crash structure around the pilot with the canard wing in front and the main wing behind. You really have got quite a lot of protection all around you. So yes, coming back to the design, it's a canard wing layout, so fully wing-borne in forward flight. As I said, with a glide ratio of around 6:7 to 1. We've got 8 different electric motors, so there's 2 on each corner, so that gives you redundancy in both the hover and in forward flight. We recently demonstrated a full corner failure in forward flight, which was you know, we didn't know how it was going to go, and it went very well, which was great. So yeah, the propulsion system has that redundancy for safety. The thing that most shocked me when we first started flying it is you just can't hear this thing at around 2,000 feet, and it flies over the top of you. You can't hear it. It is incredible, and that is one of the, like, that alone as a positive to a new aircraft type is, I think, so refreshing. You know, one of the guys at the airfield came and watched a demonstration, and you could hear Skylark hovering above us, and the aircraft was there in the same airspace. So I just think that is actually a really amazing thing to be able to experience. So coming back to the cost, you know, an R22, you've got that massive overhaul cost at the end of the 2,200 hours or 12-year cycle. We're not certifying the aircraft in the same way, so we don't have that really restrictive overhaul scheme. So everything, especially with the composite structure, you don't have that same fatigue life on the airframe like you would with something like an R22. But then you've just got generic running costs are much less with electric propulsion. You know, there's basically 2 moving parts in an electric motor. We've got an incredibly simple architecture. As I said earlier, no rotating mechanism in the motors or the wings. You know, we kept everything, you know, no variable pitch props either. Everything is simple. And so that massively reduces your maintenance cost. And when this is you doing the maintenance as an owner as well, we think that's hugely important. So yeah, the whole flight control system is essentially from a UAV, from a drone. Really, it's we're using a company in Spain called Invention who have developed a very nice redundant system that's got 3 different cores, and there's arbitration between the cores. So, from a system level sort of redundancy side, it's really safe. And using this system enables us to sort of easily transfer without modification to the hardware or software from an unmanned configuration to the manned configuration. And further down the line, we can add certain levels of autonomy to the platform, such as auto land, auto hover, waypointed missions, autopilot, complete autopilot, without having to change our systems, which is really nice. Yeah, so I think I've been through most of these points, but I wanted to show a front-on view of the aircraft so you get an idea of the sort of layout. We've actually changed this now. We've now got a four-bladed prop on all four corners. So yeah, as we've demonstrated from testing, we get about we use about a quarter of the energy in cruise. So we're using 50 kilowatts in the cruise versus around 200 kilowatts in the hover. Yeah, the all-up weight for the aircraft is 750 kilos, including 2 passengers. We think we're going to get a bit more payload out of it. We're doing various upgrades to the battery system, going to higher density packs, which I'll talk about later. Increasing the voltage, so we'll lose quite a bit of weight in the propulsion system wiring weight, because we're currently quite low voltage, which is really painful for wire weight in the vehicle. Yeah, the other big thing, all of our control surfaces are manually actuated. So you've got a conventional roll and pitch center stick, pedals for your big fin on the back. So again, in the event of any power failure, the aircraft can glide and you are in full control. Again, it's another thing, that's really nice about existing legacy aircraft, is that you do have that complete backup of being able to just get your hands on the stick and fly the machine, which we again think is essential, especially in this early stage of a new market. We want pilots to feel as safe and as familiar with the flight controls, which lends itself to the conventional takeoff architecture. So that was a loud car. Yeah, the conventional layout, so you can do all of your emergency landings without power. So just to sort of overview the transition, because quite often with it not having the rotating propulsors, people go, well, how do you do the vertical takeoff? And it's very simple. The nose will pitch up, so you'll essentially be sat back at 45 degrees. You guys are all probably very familiar with pivotal. They're more like 90 degrees, so we're a lot less severe in how far back we go, but that is how we achieve the vertical takeoff. And then the transition is very, very simple. You're essentially just pushing the nose forward into a wing-borne attitude, and then off you go. And then it's the reverse for reverse transitions. So I think it's just a nice sort of graphic to sort of give you that idea. So yeah, we've started flying. So we know in the hover we're using this much power, and in the cruise we're using this much power, which is really nice. Getting that data back and confirming what we sort of forecast from all of the modeling we did was a really nice feeling. Slightly less cruise speed, but we know we're going to be able to get a bit more capacity out of the batteries in the next model. We're going to a much higher energy density. So you can see on our prototype performance here, we're stuck at around an hour endurance, but that's going to increase up to an hour and 20 minutes, or depending on the cruise speed you select, up to 65 minutes in the production version. So that's basically going from our existing propulsion, existing battery technology, which we're using currently in the aircraft, which is around 190 watt hours per kilogram, up to 270 watt hours per kilogram. And then obviously, I heard someone saying earlier in the call, that battery technology just isn't there right now. Well, that is totally true, but it is only going one direction, and it's only going to improve over time. I think the performance we've got from this machine currently, I mean, for a lot of the flying I do, and a lot of my friends down here in the south of England do, being able to fly for an hour is quite a nice capability. And it brings all the advantages I mentioned at the start of the presentation. So we're aware that, you know, we can't compete with an R22 on range. It's just impossible with current battery tech, but it's going to get there, and it will improve with time. So yeah, you can sort of see by 2030, we envisage maybe up 350 watt hour per kilogram. And again, you know, that is being a bit conservative, because you can go and buy some cells right now, which will be 600, 700, 800. I've even seen advertised 1,000 watt hours per kilogram, but it's actually getting a cell that is commercially available, mass produced, not highly volatile, at a decent price point that we can actually sell the aircraft at a reasonable price for. So, you know, whilst I'm saying 350 watt hours per kilogram by 2030, that is for something that will actually be commercially viable for us as a business. So what we're sort of looking at primarily, as I mentioned earlier, is the private pilot market, but there are a few different business models. I don't really want to go through this in too much depth, because I don't think it's highly relevant for the people on this call. This is really actually taken from our pitch deck, but yeah, so the private pilot market is probably our primary focus at the moment. That and defense. We think there is a huge opportunity here for the private pilot community to get involved in a whole new type of flying. Again, what's great with our configuration is that you can easily convert from your existing private pilot's license, an PPLA, so fixed wing license, to type, because we have all of that existing control knowledge that you're going to just easily transfer to the aircraft, and you'll have to do a differences training and a conversion to type, which is, you know, quite similar to what you would do with, say, getting your twin rating on a fixed wing. So that's the path we're looking at. I actually circle back round to certification a bit later, so I won't dwell too much on that. So the other markets, yeah, as I said, defense. So this would be as an unmanned platform. So there's a number of different use cases there that again, you're probably all very familiar with, but you know, we can carry 200 kilos, and we're looking at integrating a hybrid solution, which we're currently working on, which is basically a small gas turbine powering a generator, so it charges the batteries in flight. Again, from a cost perspective, it works for defense applications, but the reason we're focusing on the fully electric one now is because the cost point for private guys, it might not be there, but we're going to have to see with that. But the hybrid version is very much focused on defense. And then, yeah, the training organization. So due to our configuration, side-by-side seating, it lends itself really nicely to ab initio flight training. So again, the eVTOL sector that we talk about so much, the pilot training side of it, I think, slightly neglected at the moment. Yes, simulated training is great, and I think it's an amazing tool. It can't possibly be the way that pilots are trained. It's not going to be the future of pilot training for that market. So I think we're going to position ourselves, if that market does realize the potential that it is forecasted and publicized. We're going to try and position ourselves as a two-seat trainer. So that's quite a big market, we think, in the future, and that's, you know, I'm thinking 2030 onwards. And then, yeah, emergency services, same aircraft as the sort of defense version. Again, just a nice large payload UAV system. So again, I've sort of touched on a few of these things, but our strategy as a business is quite straightforward, really. We're avoiding the commercial certification. That, as a business model, is probably our biggest point. Is we are not certifying this machine for passenger taxi services. This is not what we're doing. We're using In the US, we're going for experimental amateur built. In the UK, it's something called a permit to fly, which is then sort of transferred around Europe with each sort of jurisdiction managing that permit. So for private pilots, that gives them a bit more flexibility from a cost perspective, because a lot of the maintenance they can do themselves, and it avoids these really expensive timed maintenance slots. So your 25, 50, 100-hour servicing. Again, coming back to the simplicity of electric propulsion, the maintenance is going to be minimal anyway. So yeah, from a business point of view, we see the sort of unmanned variant also allowing, early adoption and getting a lot of hours put on the airframe is sort of the goal there, and really getting some proper use out of the platform in a military setting. We think is going to be quite a big part of the company's progress in the next couple of years. And yeah, so the big thing, we want to make sure that our customers have an amazing customer experience. So that comes down to various sort of support and maintenance programs, a proper spares department, which our customers will necessarily, they'll pay a premium for, but I know trying to maintain an aircraft to a really high standard is so it's quite time consuming, and having a really good maintenance team on the end of the phone is a big part of enjoying your aircraft. So we're going to invest a lot in that. Over to technology, we're not in the game of designing battery modules, designing motors. We're using commercial off-the-shelf products. So that's a big part of our business model. We want to find the best in class of each of our sort of major propulsion units. So that's batteries, inverters, and motors. So that's, again, from a sort of company risk profile perspective. I don't want this to sound too much like a pitch deck sort of thing, but it's quite a big part of the ethos of our business and why we're doing what we're doing. I think, yeah, so it's again, going back to sort of technology side of things, the integration of mobile networks into the aircraft and being able to monitor the aircraft in a way that's never really been done before is very unique. You get an amazing amount of data through these electric propulsion systems, from the battery management system to the motors themselves to the inverters, that all can be transferred back to our team for remote monitoring, remote maintenance, and preventative maintenance as well. So the big one for us, yeah, certification and licensing. So we've purposefully avoided the sort of commercial game. We're not trying to get commercially certified. So in the UK, we have the Civil Aviation Authority. So our first aircraft is going to be going through what's called a permit to fly. Without going into too much depth, a permit to fly is not conforming to a single sort of CS23 document. It's not going to be centered around one document. What we do with a permit is we can develop a means of compliance with the authority, pick bits of each of the regs that we want, and proportionate the risk to our aircraft size, what we're doing with it. So we essentially are presenting our own sort of set of rules that we want to conform with. And it still has to be airworthy. It's still to a set standard, but it just means that we get to have a bit more flexibility on how we certify the machine. So all the flying we've been doing at the moment in the UK has been under experimental conditions. It's in E conditions, which has given us a huge amount of flexibility to operate the aircraft in a piloted configuration, which has given us a huge amount of progress through the flight test program. As I mentioned earlier, once you get a permit to fly in the UK, generally all European nation countries will accept that permit in those areas. So the CAA has a great reputation for safety. So generally, it's easily transferable across. So in the UK, we've got similar governing bodies to the EAA. So that's called the LAA in the UK, and there's another one called the BMAA. So eventually, we will, once we've got the first permit directly with the CAA, we will be sort of delegating that permit issuance to an organisation, either, well, both probably, the BMAA and the LAA. But that's, again, it's sort of from a certification perspective, for a customer experience perspective, they've been certifying kit planes and the like for years. So it'll be a nice customer experience, we hope, rather than having to deal directly with a huge authority like the CAA. And in the US, it's a breath of fresh air, really, from a certification perspective for us, because we're going to be doing the experimental amateur build. The one barrier at the moment for us is the licensing with powered lift rules due to come out later this year. But we're bringing the aircraft over to America in a few weeks for Oshkosh, where we'll actually be flying it into the show. And that's under an experimental amateur built certificate, but purely for conventional flight, no vertical yet. But what's amazing is that, you know, we technically are able to actually start selling that aircraft now under an experimental amateur built category. So the US have that amazing infrastructure and sort of licensing system in place, which it really does open the market up to aircraft like us to start selling and you know, generating revenue and getting aircraft out to customers and flying. So yeah, the timeline of the company, I guess, from the start, we started this process in 2019, which feels an awfully long time ago. And the way we went about it is sort of some initial designs, doing a lot of CAD work, a lot of CFD work. We built 3 subscale versions, which were third scale prototypes, all with slightly different layouts and configurations, and then we ended up on a final design. We did all of the transitions, and then we finally said, look, we're happy with this. Let's not waste any more time. So we went and locked the design, invested in all the tooling. So with a composite structure, every single component, every item on that fuselage is composite. So we then had to design all the tooling, and then get developing the first airframe, which was serial number 1. So then end of last year, we started the first test flying, where we started with the sort of hover testing. Then at the end of last year, so the hover testing again is just basically tuning the aircraft. So your PID controller that essentially makes it stable in flight. We have to go through quite a big process, making sure that it's super stable. So we did that at the end of last year. Then we installed all of the manual controls systems. So that's linking up the control surfaces, fin and rudder, etc., to the aircraft. And then we began conventional flights at the beginning of the year. And we've we've applied for our permit to fly for the first airframe. So we've begun that certification process for the next fuselage or next airframe. So we're hoping by the end of this year to have the next airframe built. And then hopefully by mid next year, we can start delivering aircraft to customers with a permit in the UK. But again, in the US, under experimental amateur build, we should be able to start selling then as well over there. So that's in a nutshell. I don't know how long that's been. Oh, half an hour.
No,
Is that
we
right?
have a few minutes
Anyway.
left. Yeah, we have about a little less than 10 minutes left.
Okay, well, I'm done. So you can ask me any questions you like.
Absolutely brilliant. Based on your go-to-market plan, I think you're going to have some very positive attention in Oshkosh. That's the right kind of market for that market entrance.
Yeah,
It's you're going to be a hit there. What questions do we have, folks?
A very great presentation. Actually, I really love your design. I mean, from a aircraft designer to another aircraft designer, I have to say, the simplistic and the elegant configuration, design a complex airplane can be done, and to achieve a elegant, simplistic design that performs well, that's an art. So my congratulations to you. Quick question.
thank you.
One comment. I do like, I think your emergency response slide should stand by itself with a separate page altogether. I think there's a lot of opportunity there as well, especially the simplistic operation, low training, and low cost. A lot of emergency agencies, they don't have a huge amount of budget, but they definitely can use the capability. So yeah, we can brainstorm more later. Quick question on the US market. Have you taken a chance to look at the newly revised update, significant update, the light sports category as a follow-up possibility?
100%. Yeah, I mean, so, as a business, our goal is to get aircraft in the air all over the world as quickly as possible. The light sport category is where we'll end up for the aircraft, 100%. But we've got customers already itching to receive their machines. So, the experimental amateur build is basically a stepping stone to eventually light sport certification.
Okay. Sounds reasonable, logical. Thank you.
And Michael, you can unshare the presentation when you're ready. We'll be able to see each other a little bit better. And Mike Hirschberg, I see your hand is up. Fire away.
Yeah, thanks. So that was what Johnny asked, was kind of what I was wondering about. So maybe as soon as next month or later this summer, the FAA is supposed to come out with the light sport aircraft Mosaic, the modernization of special aircraft airworthiness certification. So basically, you could have a light sport aircraft that's not kit built, but factory built, and that includes for these smaller aircraft that they're using electric vertical takeoff and landing capabilities. So that's just, I assume you're well aware of that, but I didn't hear you say, I never heard you say the word Mosaic, so that's what I was fishing for.
Yeah, fair enough. No, we are aware of it. I think there's quite a few things that need to happen for that to eventually go through, not least from a licensing perspective. So what might, again, our configuration allows it to be flown conventionally. You can take off on a runway. So in the event that we want to deliver aircraft to customers, they can fly it as a fixed wing until I see the pilot licensing being more of a barrier to us selling in the light sport category than anything else, because there is not enough aircraft that you can do the training on for powered lift. So again, from a training perspective, we really should be that aircraft. I don't. Obviously, there's Air One who are another company that have a similar configuration, but less so with the conventional fixed wing side of things. So there's a few, but I think the pilot licensing needs to be given a bit more time.
Yeah, no, good answer. I mean, I think it's the final rule comes out. But certainly the FAA has shown with type certificated powered lift aircraft that they have to figure out exactly what they want for pilot certification for those powered lift aircraft. So, okay, well, I'll let somebody else ask the question.
And also, the FAA tends to do announcements at Oshkosh, so maybe we'll learn more about the next phase of Mosaic in a couple weeks next month. Ken Swartz, I see your hands up. Fire away.
Great. Hi. First of all, I do want to confirm that we do want Skyfly to speak at the Electric Aircraft Symposium in Oshkosh on the 19th and 20th. Andy had actually reached out to me a week or two ago, mentioned that you were coming, and I said, yes, by all means. So if there was anything lost in translation, we definitely want you to attend. I also see some others on the call, such as Brandon and some of the other people on the call here who are developing innovative eVTOLs. If you're interested in speaking at the Electric Aircraft Symposium on the weekend before Oshkosh, please reach out to me. I've been doing my own outreach to quite a few companies, but it's been sort of hard to cover the complete landscape. Of course, we know that a lot of people are coming to Oshkosh for that personal pilot experience. Some of them may not know of the Electric Aircraft Symposium. We're, of course, very strong on the eVTOL side, but there's a larger community out there. So please reach out. Found the presentation very interesting. I came in a little bit late. Tell me a little bit about how much pilot have you been flying, both remotely piloted and piloted, and is there a trade-off in terms of what you do remotely versus piloted for your flight testing?
Yeah, it's a really interesting one. I think Brandon, you'll be able to allude to this. You can start with tethered. What we did, we started with unmanned tethered tuning, essentially, but very quickly you're limited on whether that's the length of the tether you're using. And very quickly you find you're going to want to expand the envelope, but and what we actually, because of what we've got in the UK is an amazing system under E conditions, which enables you to pilot the aircraft under your own risk. So we actually decided we obviously flown unmanned at a third scale forever. So what we actually did, because where we ended up test flying was not in a huge amount of space, it was actually safer for us to pilot the aircraft and tune the aircraft after we'd done the basic tune in the tethered scenario. It was actually safer for us to pilot the aircraft and to do the final bit of tuning untethered with pilot in it. So we actually haven't done it on full scale aircraft. We haven't done a huge amount of unmanned flying. That being said, we again see it as a risking the airframe unmanned is quite easy to, you get ahead of yourself through your flight test schedule. Whereas when you've got a pilot on board, you take everything a lot slower. It's much more sort of, everything's risk assessed in a way that you'd never have any issues with ruining an airframe because you're doing everything so slowly. So we actually didn't end up doing any real unmanned testing, as you would imagine. Especially long range fixed wing flying. It was not something we wanted to risk doing unmanned. We've only got one airframe at the moment, and we actually evaluated that the risk to that would have been higher doing it unmanned. There's too many factors that were unknown if you tried to go into a conventional fixed wing flight test program with it unmanned.
That is so well said. First of all, man, congratulations. It's just a great company in this space. Congratulate your team and yourself. I know firsthand how difficult some of this stuff is. And to address the question, I mean, you just nailed it, right? To layer on a remote piloted scenario on top of an already difficult sort of thing that you're doing is just layering difficulty on top of difficulty. And so we're very cognizant of that. We dealt with that with our large scale prototype. And we are going to fly a conventional version of our aircraft first, right? To test the envelope from a STOL variant backing into the STOL sort of environment, and then working into the, the vertical system. But just all that to say, just really well said. Amazing company, amazing job. You guys are kicking ass. Really appreciate everything you're doing. Love this, love the approach, and seems like you built a.
Thanks, Brandon. We appreciate that.
Well, that about brings us to time. And on the topic of remote operations, our meeting next month will be about that topic. So we're going to bring in an organization that has built, they sort of have pre-built remote operations systems, stations, onboard plugins, as well as remote operations centers. So that'll be a timely conversation. Michael Thompson, fantastic work, excellent presentation. We all enjoyed it, and looking forward to hearing more and meeting in person in Oshkosh next month.
Yeah, looking forward to it. Cheers. Thanks a lot.
Keep up the great work. Thanks all.
Thanks.
Appreciate you being here, everyone.
Bye.
Thanks.